To Physics Lab 2. My name is Kiefer. So for the introduction, the purpose of this experiment was to observe an object drop from rest, and that object has to drop somewhat slowly to observe its drag. And the focus is to observe Newton's second law with a net force not equal to 0, and F net is calculated with the force of gravity plus the force of drag in this experiment. So in this experiment, we're gonna have to know a few equations. One of these is calculating the final velocity, which is Vf equals Vi plus the F net divided by m times delta t. F net, as I said in the last slide, is calculated by the force of gravity plus the force of drag. The force of gravity is calculated through negative mg, and the force of drag is equal to negative v squared times v hat. So this is the experimental data using the tracker software, and I'll just play this video. So as you can see, as the object drops, I'm manually tracking the data points at intervals of 0.033 seconds, as you can see on the graph, and the y is decreasing at an increasing rate due to acceleration of gravity. So this is the code I used to calculate the data with gravity, and so I inputted ball.m and that set that equal to 0.2. I updated the delta t to 0.033, added the gravity, which is 9.8 meters a second. I updated the t to put the data point where it is equal to 0. I updated the ball.pos to update the starting position of the object, and then I updated the object's velocity formula, which is ball.vel equal to ball.vel plus F net divided by ball.m times delta t, which is just the Vf is equal to Vi plus F net divided by m times t. And we're on to the gravity plus drag code, which is basically the same, but I added in b is equal to 0.007 and calculated the F net differently. I put all of these datas into a graph with the blue as the original data, which is the tracker, orange as the experimental, I'm sorry, not the experimental, with the calculated with gravity only, and then the gray is the calculated with drag. So as you can see, the experimentals are faster than, or the calculated is faster than the trackers, and that the gray, which is the one with drag, falls a little bit slower than the orange, indicating that drag is pulling the object up, so it's making it fall slower. So now we're on what does it mean? Do any of the models have terminal velocity? And I would say none of these models have terminal velocity because the force of drag does not equal the force of gravity in any of these models. And what these mean is that acceleration is equal to 0 when the force of drag is equal to force of gravity. So what if the object was thrown downward? Would the terminal velocity be the same? The terminal velocity for each one would be the same, but the difference in this is that the object would reach terminal velocity faster. And that concludes my presentation.